Good morning, good afternoon, good evening. My name is Professor Rob Fleming, and I'm here to deliver the first of a 7-part lecture series on perspectives on energy and environment, and the course is Principles and Methodologies for Sustainable Design. Last week we looked at integral theory and integral sustainable design as holistic frameworks to better understand what sustainable design can and perhaps should be. And this week we're going to use those frameworks to delve more deeply into energy and environmental issues. So the goals of these lectures are to develop a basic level of energy literacy so that you can make rational systems choices when designing projects, but also to develop a deeper sense of environmental awareness so that you can understand how those energy choices impact future generations and their ability to have a quality of life. This will lay the foundation for the second half of the course, which will get into sustainable design in much greater detail. If you remember from week 1, we studied the historical context of sustainability and learned that when there are new energy sources emerging, we see great leaps in societal consciousness. And right now we perhaps could be in that transition to a new worldview. It's pretty exciting, actually. But we also know that energy choices have all kinds of impacts on our daily lives today, and certainly of those lives in the future. And so we looked at, when we think about energy, we look at a great resolution. And are we thinking about energy as a supporter of unlimited growth, as in Adam Smith's free market, or do we see our energy choices as part of empathy for the future generations, as the idea of saving energy for the future and protecting the environment for the future? Ultimately, I think that we're trying to do both, and we're trying to create a virtuous cycle where the decisions to make profit are balanced with the decisions to save the environment and or make better energy choices. So natural resources exist in 3 forms. The first is stocks, which are what we think of as fossil fuels, uranium, any kind of material that would take perhaps 500,000 to 1,000,000 years to regenerate. And some worry that even with technological advancement, in other words, exploring the reserves, that we will eventually run out of stocks. The other major resource is renewable stocks. We think of these as forests, soils, aquifers, water, all of those kind of things that can be renewed and can be restocked. Some worry that those renewable stocks cannot be replenished fast enough to meet growing demand. The third type of energy is flows: wind, solar radiation, rivers, those things which generally exist in perpetuity, which can be harvested for energy. And some worry, though, that the cost to deploy the energy systems to harness those flows are too expensive. And so we're going to be using these 3 types of resources as the framework for studying energy in these lectures. So just to understand a little bit better, renewable stocks could be fuel wood, for example. Food is certainly an energy source. And biomass, as we understand it today, are all renewable stocks, meaning that we can make more of these or grow more of these kinds of stocks to get the kind of energy that we might want. Renewable stocks, non-renewable stocks might be oil, coal, natural gas, or nuclear uranium, and these are substances or resources found in the earth that have been there for millions of years and would take millions of years to regenerate. And then renewable energy, we think of hydro. These are all flows again. We think of wind, we think of solar, and we think of the flows of temperature under the ground. So these are not only renewable but actually perpetual. So I always wonder why we don't use a different term for these types of energy, but I'm not going to try to solve that today. How these different energies play out in the real world, you can see, for example, at the bottom there, petroleum, being oil, is the largest or highest amount of energy use that we use. And on the right, you can see how these different energy sources are delivered to different kinds of sectors of the economy. So petroleum, coal, and natural gas, fossil fuels, or non-renewable stocks are the 3 largest types of energy that we're using. Whereas you see nuclear, for example, in red is a much smaller number, which is also non-renewable. And then solar, hydro, wind, and geothermal, you see, are relatively small, although growing rather quickly in the world economy. And finally, of course, biomass is actually used pretty widely to generate energy also. So the framework that we covered last week, integral theory, is going to be used to study each of these energy systems in detail. So we can understand energy from an experience or subjective point of view. So for example, I don't like the look of those wind turbines. That seems relatively unimportant when you think about the future of renewable energy, but that kind of objection has slowed many wind farm construction projects. So personal experience and opinion actually do have a lot of weight to play in how we move forward. Certainly the facts are important. The objective aspects of individual elements in time and space, these are not disputable. So for example, global temperatures are 2 degrees Celsius higher than 10 years ago. Well, actually that's probably not true. That's a little bit of a typo, but let's keep going. Culture and society, we look at the subjective values of the collective, meaning, for example, an entire country or large part of a population could say, we believe that nuclear power is dangerous. And that then can also drive politics and public decision making. And finally, understanding how the physical systems interact in the environment is critical to making energy choices. So for example, burning fossil fuel is emitting CO2 in the environment and is impacting the climate in a complex system. So the 4 of these together gives us a framework to evaluate and better understand each energy choice in detail. So for example, just a little bit more here. So we would like to know, for example, facts. We'd like to know the units and also the units of work. These are important vocabulary terms that we should know. How is the energy used? Is it used for machinery? Is it used to create electricity? Is it used to feed people to do work? And is the energy type a flow, renewable or non-renewable stock? Are there incredible profits? Is it lucrative? This will affect self-interest. What are the externalities of a particular energy choice? And finally, what is the reserves available on these kinds of energy choices? It's difficult to quantify, actually. In terms of the perspective of culture and society, we want to know which worldview the energy source is associated with. We want to know some of the societal benefits of the energy choice. We want to know, for example, what are some of the societal costs of choosing different forms of energy. And obviously environmental damage leading to economic damage is a huge one, not just for today, but for future generations. So this quadrant looks at the ethical foundation for different kinds of choices that we make. And then when we look at experience, we might think of quality of life. How much does the energy source raise our quality of life in terms of comfort and convenience and functionality, which has a great relationship with level of consciousness development in society. So we can become a more intelligent society and evolve culturally. And certainly the sensory impacts associated with different kinds of energy can vary and have impact on whether those energies are viable or not. Systems point of view looks at decentralized. Do we have a centralized or decentralized system? That has a big impact or is important for considerations in sustainability. What kinds of infrastructure does it need? What is the amount and complexity of infrastructure? Is it a closed or open loop system, meaning are there a lot of externalities that come out of the system or very few? What are the impacts to the ecological systems on the planet? And finally, does the system have a sense of reliability? In other words, in different kinds of situations, is it resilient? And so that would be the systems perspective. So putting all those together, we can begin to build a framework by which we can look at all of the different energy sources that we use today and into the future. Should be very useful to compare them. So that's the end of this first video. If you're a grazer, continue on to the next video directly on the Vimeo site. Feel free to follow me on Vimeo so that you'll know when new lectures are posted. And if you're a student or scholar, go ahead and continue on to the next video and stay tuned for more directions on how to use the CourseSight site. Thank you.